Question 4 is based on equilibrium of forces. This body is in equilibrium with three coplanar parallel forces. To be equilibrium, there should be three factors of this body. The first one, the forces should be parallel to each other, and the opposite force should be equal to the summation of the other two forces, as well as these forces, all the forces should be in a coplane. So those are the things should be fulfilled in this body to be in equilibrium. The first question, using arrowheads, mark the following forces in figure. The tensions T1 and T2 exerted by two strings on rod. T1, T2. And the weight of the rod is acting from the midpoint of the rod, that is W. What is the relationship existing between T1 and T2? T1 and T2. The summation of these two equal W. No, that should not be the answer. Then the T1 and T2 are equal. T1 equal T2. Write by an equation the relationship among T1, T2 and W. So that should be W equal T1 and T2. So swing is example for the equilibrium of body under three coplanar parallel forces. When we are playing swing, the forces are exerted like this. Then, fourth question. If the mass of the body of the rod is 200 gram, what is the value of W, it means weight, in newtons? Let's see. W equal mg. We know this. Then mass should be converted into kilogram. 1000, and gravitational acceleration is 10. Then after solving, we get that is 2 Newton. Okay. Then indicate the values T1 and T2 in Newton. So if the overall resultant, it means W is 2N, T1 and T2 should be 1. 1 Newton, 1 Newton. Next part. Figure 1 below illustrates a helical spring connected to an immovable support on a table. The other end spring is contact with the block of wood. Figure 2 below show how the spring is compressed by applying horizontal force T on the block of wood. Assume that there is no friction between block of the wood and the surface of the table. So this is a spring, helical spring, and block is fixed here. Then it is compressed in figure 2. Name the form of energy stored in the compressed spring. So you can see the spring has changed its shape. It means the energy has stored by changing its shape. So we call this elastic potential energy. Elastic potential energy is a type of mechanical energy. So it can release energy by changing its shape. So as well as object can come to the original position once the applied force is removed. So that's what happened in elastic potential energy. To what form of energy will the form of energy stated in 1 above be transformed when P force is removed? You know that after removing this force potential energy, going to be converted into the kinetic energy with the movement. When that body starts to move, that potential energy start to convert into kinetic energy. If the amount of energy stored in the compressed spring is 16 joule, the mass of the block of wood is 0.5 kilogram. Calculate the initial velocity of the block of wood. So the equation for kinetic energy is Ek equal half mv square. So we were given a kinetic energy that's 16 joule, half. Mass of the block is 0.5 kilogram, and we need to find the velocity. So after solving this, 16 into 2 and divided by 0.5 equal v square. So let's see how to solve this. 32 by 2. V square, finally we get 64. 64 means V is 8 meters per second. So V is 8 meters per second. So this is structured as equation. So you must write the answer with the standards units. State the nature of motion of the block of wood along the table after it released from the spring. So, according to Newton's first law, until unbalanced force is applied, the objects at rest remains in stationary, while object in the movement moves with uniform velocity. So, the unbalanced force is a force that applies or change the position. The unbalanced force can move an object by changing its position. So here, the nature of movement is that is going to move with uniform velocity or uniform speed. If there was a constant friction between surface of the table and the block of the wood, and if the table had considerable length, draw the velocity time graph for expected motion of the block of wood after it has been released from the spring. So frictional force is the opposed motion of the object. That is a resistive force that acts opposite to the motion. So here it is mentioned that friction is constant. Then the velocity should be reduced in a constant manner. So you should be given you should get a graph like this. Using a ruler, you should draw like this. And as well as you want to name axis. Then when we name axis, this is time. Time is measured by seconds. And this is force. Force by Newton. So when you are selecting axis of a graph, so this horizontal axis is named X, and vertical axis is Y. X axis, we want to give independent variables. And for Y, we want to select the dependent variable. So here time is independent with the force, frictional force. Therefore, time should be put to the x-axis, and force is gradually it is changing. So it is the dependent variable. So that is how we want to plot this graph. And for plotting this graph shape, you are given a 1 mark, as well as for keeping this graph with the axis labeling, you will be given another mark. Okay,